Exercise 1.41 is a set of 3 questions on negative and fractional indices for A-level Pure Maths Year 1. Question 1. A. Without using a calculator, evaluate 8 to the power 1/3 plus 81 raised to the power a quarter. B. Find the values of y which satisfy the equation 8 to the power y, all of that raised to the power y, times 1/32 raised to the power y equals to 4. For A, 8 can be written as 2 to the power 3, and we raise that to the power 1/3, plus. Similarly, 81 can be written as 3 to the power 4, and we raise that to the power a quarter. Now 2 to the power 3 raised to the power 1/3 can be written as 2 to the power 3 times 1/3, and that is using rule number 3 here, and that would reduce to 2 to the power 1. And so this is equal to 2 to the power 1, and similarly, that would be 3 to the power 1. And this is therefore equals to 2 plus 3, and our answer is 5 for question 1A. B. 8 can be written as 2 to the power 3, and we raise that to the power y, and to complete, we raise the whole thing to the power y times 1/32 can also be written as 2 to the power 5, so that will be 2 to the power 5, all of that raised to the power y. And that will be equals to 4, which is 2 to the power 2. Simplify the whole thing, becomes 2 to the power 3y squared times 1/2 to the power 5y equals to 2 squared. Now using rule number 5, we can rewrite this part of the equation as follows. 2 to the power 3y squared times 2 to the power minus 5y equals to 2 to the power 2. Now we have the base here to be 2 and the base here to be 2, so we can go ahead and use rule number 1 to simplify the left-hand side of this equation as follows. 2 to the power 3y squared minus 5y, and that will be equals to 2 to the power 2. Now we have an equation here where the bases on both sides are 2. That implies that the powers on both sides must be the same. So that means 3y squared minus 5y is equal to 2. Rearranging, we get 3y squared minus 5y minus 2 is equal to 0. Now if I multiply 3 by minus 2, I get minus 6. If I break it down to get 2 factors, which must add to give me minus 5y, then I'll have minus 6 and 1. And so I can replace minus 5y by minus 6y plus y. And I'm going to get 3y squared minus 6y plus y minus 2 equals to 0. Then I can factorize as follows. 3y comes up, brackets, y minus 2, and then 1 comes out here. I get y minus 2 equals to 0. And so finally I get y minus 2, brackets 3y plus 1 equals to 0. And so solving, I get either y is equal to 2 or y is equal to minus 1/3. And these are the 2 solutions for question 1b. Question 2. Express 3 to the power 2y minus 3 to the power y plus 1 minus 3 to the power y plus 3 equals to 0 in terms of w, where w is equal to 3 to the power y. B. Hence, solve the equation 3 to the power 2y minus 3 to the power y plus 1 minus 3 to the power y plus 3 equals to 0. So we need to rewrite this equation here. We can do that by writing 3 to the power 2y as 3 to the power y, all of that squared. And so if I do that, I'm going to get 3 to the power y all squared minus. And using rule number 1 here, on this term, I'm going to get 3 to the power y times 3 to the power 1 minus 3 to the power y plus 3 equals to 0. And because this 3 to the power y is w, we can replace this by w, this by w, and this by w. And then we get w squared minus 3w, because 3 to the power 1 is 3, minus w plus 3 equals to 0. And then we simplify this. We're going to get w squared minus 4w plus 3 equals to 0. And so we have now written or expressed this equation here in terms of w. And here is the answer required. So that's for A. For B, we require to solve this equation. But we know that this equation can be represented by this quadratic equation here. So it means if we solve this, we can get the values of y required. So we know that w squared minus 4w plus 3 equals to 0 is the same as this, the equation that we are required to solve. And then we can go ahead and factorize this. I'm going to get w and w here. Looking at the factors required, we need minus 3 and then minus 1 here. That means w is equals to either 3 or w is equals to 1. But we are required to find the values of y. Well, we know that w is the same as 3 to the power y, and that would be equals to 3, or 3 to the power y equals to 1. If I write this nicely, I'm going to get 3 to the power y is equals to 3 to the power 1, or 3 to the power y is equals to 3 to the power 0, because 3 to the power 0 is 1. So because the bases are the same, the powers must be the same. And so we can finish off this by saying that y is either equals to 1 or y is equals to 0. And so these are the two answers required for question 2b. Question 3. We are required to simplify these two expressions here, one for A and one for B. So for A, we are going to expand the numerator, this times that one, plus this times that, and so on. And so for the first term, we're going to get x to the power 3 over 2 times x to the power a half. So that will be this one times that one. And this is the same as x to the power 3 over 2 plus half, according to rule number 1 here. And this will reduce to x to the power 2, because 3 over 2 plus a half is 4 over 2, which is 2. In the same way, this one times minus this will be x to the power 3 over 2 times x to the power minus a half. That will give us x to the power 3 over 2 minus a half, which is x to the power 1. So if you do all the expansion according to these rules here, for the numerator, you're going to get x squared minus x plus x minus 1, all that over the denominator. If you expand the denominator accordingly, we will get x cubed minus 2x squared plus x. So x to the power 3 over 2 minus x to the power a half times itself, x to the power 3 over 2 minus x to the power a half will give us this, because x to the power 3 over 2 times x to the power 3 over 2 is equals to x to the power 6 over 2, which is x to the power 3. And that's where we go for the first term. If you do the expansion, all of it, we're going to get this for the denominator. Now we can see that for the numerator, this will cancel with that, because minus x plus x equals to 0. And so we are going to get x squared minus 1 over, and I can factorize x out for the denominator. So I'm going to get x out, I get x squared here, minus 2x plus 1. And we need to also recognize that the numerator is the difference of two squares. So we are going to get x plus 1 and x minus 1. For the denominator, we can leave this x out and then factorize the quadratic expression here. If I do that, I'm going to get x minus 1 and x minus 1. So now I can do some cancellation. This will go with that, and I'll be left with x plus 1 over x brackets x minus 1. And that's the final answer required for question 3a. For question 3b, the numerator here can be written as 4 times 2 to the power n plus 1 minus 2 to the power n times 2 to the power 4 over, and we can leave the denominator as it is, n plus 1 minus 2 to the power n. Sorry, this is 2, not 4. What we need to do now is rewrite the numerator as follows. 4 times 2 to the power n plus 1 minus 4 times 2 to the power n, because 2 to the power 2 is 4. And then I'm going to leave the denominator as it is again. So 2 to the power n plus 1 minus 2 to the power n. And then if I factorize the numerator, that is bring the 4 out, I can get 4 brackets 2 to the power n plus 1 minus 2 to the power n divided by 2 to the power n plus 1 minus 2 to the power n. And you can see that this is the same as that. And so we can cross out this and that, and then we'll be left with 4 as our final answer. So this is the end of this session on negative and fractional indices.